All right, guys, this is your first video regarding quadratic transformations. And this first one we're going to talk about is horizontal and vertical translations. So weird kind of use of words there. Transformations being more of an all-encompassing term. Translation is when we're just kind of moving stuff around. So first thing to notice, you'll see this twice throughout this set of notes, is that we're always going to do these from vertex form. That's why we've been practicing in vertex form a lot. And I'm going to go ahead and tell you now to probably pause it on this slide and take down these notes because you're going to need them as we go forward. Specifically, the stuff that I put in blue and red writing. So changing a number inside of parentheses, okay, we'll move it left or right. However, adding goes to the left and subtracting goes to the right. That's kind of backwards land of what you would think. However, if we change the number out on the very, very end of vertex form, that's going to cause us to go up and down, but up is adding, which makes sense, and subtracting is going down, which makes sense. So it's kind of weird. Left and right is backwards, up and down is the way your mind thinks of it, okay? So again, pause it here, get these rest of these notes down. I'm gonna let you unpause it when you're done. You can continue on with the video. So let's go through a couple of examples. Here we're gonna start with what's called a parent function. A parent function means that's where that's our original graph, okay? Yes, our parent function here is extremely basic, but you'll notice when we get down on this next example, our parent function can be anything. It can be complicated like this one down here on the bottom, which we'll get to later. Just know that we're starting off with this very basic parent function, and we're going to do this first example. So we're going to go first example, starting from the parent function, and we want to move down 6 units. Well, if we want to go down 6 units, okay, that means out on the very, very end of our quadratic in vertex form, we need to have a -6 because down means subtract, and it means out on the very, very end. So we'd have x squared minus 6 as our new function. Next, our second example, and we're going to start with the parent function again and go down. Notice this, so I'm not using this one for my next example. I'm starting with the parent function. We want to go left 5 units. Well, as it says in your notes, left and right is inside the parentheses. And you say, well, Mr. Earl, there's no parentheses at the parent function, so where do I put it? Well, think about what vertex form usually looks like. It's usually some number x plus or minus h quantity squared plus or minus some value of k. Really, these are just pluses, but you get the gist. Okay? So if there's no parentheses, where would they be? Well, they'd be around the x value with the squared out on the end. So if we want to go left 5, we need to make some parentheses. X, and now let's talk about what left 5 is. Well, left is adding, okay? So we need to add 5 inside the parentheses that we created. And you say, Mr. Rowe, what about the very end? Well, we didn't go up or down. We started with the parent function, so we have nothing out here on the end. All right. Now let's combine a couple of these things. And again, feel free. Pause this, rewind this, listen to it back. Do what you need to do. Let's go up 2 units and right 4 units. Okay, so we're starting with the parent function of x squared. If we want to go up 2 units, that's a +2 way out on the end. Okay, you can write that one first if you want. You can save it for later, whatever floats your boat. The horizontal translation, though, that's what requires us to set up some parentheses like we did in our red example here. So if we have our parent function of x squared, and we want to take that thing right 4 units. Well, to me, right sounds like adding. But remember, in the parentheses, it's backwards land. So we're actually going to subtract 4, because that's what our rule told us to do on the last page. So -4 will move us right 4. That one's done. And up 2 means +2 out on the very end. So we do a +2. Remember, you can always check these in your calculator, and this is the one I'm going to check because it's kind of got the most going on. Our parent function was x squared. We are now stating our new function is x -4 squared +2. And what we're going to be looking for is, where does the vertex go? Does it go up 2 and right 4? So here's my parent function coming in right here. And we want it to go up 2 and right 1, 2, 3, 4. So let's see if it comes in right there. Now, you don't have your graphing calculator at home, but Desmos is even faster and easier to do this with. And so you'll see we went up 1, 2, and right 4, which means our answer is correct. Great way to check these is Desmos. The final thing we're going to talk about is what if the parent function is already a little bit complicated, okay? And then what happens when we transform a couple of pieces in it? This is harder than the one you have on your actual work today. So, little quick review. Let's think about where's the vertex for this thing. This is at -7 because we take the opposite, comma -2. And then our new vertex is at -3, comma -5. So you can tell it changed, and it changed in both directions. If you want to do it like that, you can then just tell me how the vertex moved, or we can use these new rules that we have. So let's talk about right here what happened. Inside the parentheses, we went -4. So we went from +7 to +3. That's subtracting 4. And subtracting 4 inside the parentheses means we went right 4. Okay? Then, out on the very end, we went from a -2 to a -5. That's subtracting 3, which means we went down 3 as well. These two translations combine to be our answer from our parent function to our transformed function.